In this video, we're learning to solve systems of linear equations by a process called elimination. Elimination is done by removing one of the variables. As you can see in this example, our first equation is 4y plus 2x equals 12, and our second one is negative 4y plus 3x equals 8. So in this case, we will want to eliminate the y's. If we add the bottom and top equations, 4y plus a negative 4y is 0y, so they cancel out. For the second column, 2x plus 3x is equal to 5x. For the last column, 12 plus 8 is equal to 20. Now our y's disappear. We can divide both sides by 5, which gives us x is equal to 4. In order to solve for y, we take that value of x, which is 4, and we replace in the original equation, it doesn't matter which one, we replace the x with the value we just found, in this case 4. And we get 4y plus 2 times 4 equals 12. This simplifies to 4y plus 8 equals 12. And if we subtract 8 from both sides, we get 4y equals 4, divide both sides by 4, and we get y equals 1. That means that the solution for this system of equations is 4, 1. In other words, both equations are true when x is 4 and y is 1. Let's look at another one. 6y minus 7x equals 13, and negative 4x plus 3y equals 9. So the first thing we need to do is to shuffle the terms around so that we get our x and our y's in matching columns. So here we'll just swap the 3y and the negative 4x. And we can see that although we don't have any that match exactly, the 3 and the 6 are quite similar. So what we can do is we can multiply everything in the second equation by 2, and then we get 6y minus 8x is equal to 18. Now our y's are going to cancel out easily, but in this case, instead of adding them, which would give us 12y, we're going to subtract everything in the equation. So 6y minus 6y is equal to 0y. Negative 7 minus a negative 8 will give us a positive x, because that's negative 7 plus 8. And 13 minus 18 will give us negative 5. This means x is equal to negative 5. So the same as in the last example, we will use the value we just found for x, and we will put it back into one of the original equations to replace the x value. And when we simplify that, we get 6y plus 35 equals 13, because negative 7 times negative 5 is positive 35. And when we subtract 35 from both sides, we get 6y is equal to negative 22. Divide both sides by 6, and we get y is equal to negative 11 over 3. This means that the solution for this system of equations is negative 5 and negative 11 over 3. Let's look at a word problem. Shadow Bluff Farm has a total of 17 sheep and ducks. If the animals have a total of 52 legs, how many sheep are there? So first we need to create some equations. So s plus d equals 17 means that the total number of sheep plus the total number of ducks is equal to 17. In other words, there's 17 of them altogether. The second equation deals with the legs. The number of sheep legs will be the number of sheep times 4. The number of duck legs will be the number of ducks times 2. And all of those legs combined together will be equal to 52. So the easiest thing to change here is to multiply everything in the top equation by 2, which gives us 2s plus 2d equals 34. And now again we can subtract. 2s minus 4s is negative 2s. 2d minus 2d will give us 0d, so they cancel out. And 34 minus 52 will give us negative 18. We can divide everything by negative 2, which will give s equals 9. We can take that 9, plug it back into our original equation. 9 plus d equals 17. If we subtract 9 from both sides, we get d equals 8, meaning we have 9 sheep and 8 ducks. So the solution to this system is 9, 8. The answer to the word problem, there are 9 sheep. So to review, we need to rearrange the equation so that the similar variables are lined up above each other. So the y's are above the y's, the x's are above the x's, and so forth. We need to multiply or divide everything in one or more of the equations by the same number so that one of the variables can cancel out. We can then add or subtract the two equations and solve for the remaining variable. Use that variable in one of the original equations to solve for the second variable.